Good morning, good afternoon, good evening. We are back and better than ever. Some more Minha Alma, integration by substitution part 2. Let's get right to it, shall we? I gotta scoot on through what we've already done. Look at that beautiful, beautiful work there, and let's do another one. Okay, so we're gonna go with part B here. I'll change the blue as not to confuse. And again, we're trying to figure out what to let u equal here, and you're gonna get better and better and better at this. Okay, so I have an x and I have 1 minus x squared, and you might think, hey, nothing's working here, but watch what we can do. U equals 1 minus x squared. Well, du is equal to negative 2x dx, okay, which isn't quite my x here, okay, but look what we can do to manipulate that, to make that work, okay. So I am going to say that this integral is equal to the integral of e to the u du, okay? But we have a problem because right now they're not equal, because du is equal to negative 2x dx, and I need du to be equal to x times dx, because I've already taken care of 1 minus x squared. I've replaced 1 minus x squared with u. So right now I need x dx, and I have du equal to negative 2 x dx. Well, I have to take care of this negative 2, and I can make this equal by multiplying the entire integral by negative 1/2, because negative 1/2 times negative 2 is positive 1, which gets me the x dx. Okay? Back that up if you need to see that again. Okay? And then this is no big deal at all, because the integral of e to the u is simply e to the u. So this becomes negative 1/2 e to the u plus c, which in turn becomes negative 1/2 e to the 1 minus x squared plus c. Again, if you don't believe this is working, you just take the derivative of this and you will end up with the integrand, xe to x times e to the 1 minus x squared. Okay, another example. Last example, actually, or last two examples, integrate with respect to x. So we're going to take the integral for part A here, the integral of cosine cubed x sine x dx. Okay. So again, I'm looking what is going to most benefit me here. If I let u equal sine x, then the derivative of that is going to be cosine x, and I have cosine cubed x. So I am going to say that u is equal to cosine x. Okay? And then du is equal to negative sine x dx with respect to x. Again, this dx means with respect to x. Okay, so then I can say that this equals the integral of u cubed, right? Because u is cosine x. I'm replacing cosine x with u, du. Okay, but I have a slight problem. Du equals negative sine x dx, and I need it to be positive sine x dx. So I have to compensate for this negative, right, by multiplying the entire integral by a negative, thereby a negative du is equal to a positive sine x. So it works out swimmingly. So now we have this being equal to negative u to the 4th over 4 plus c. And then all I have to do is simply replace u with cosine x, so that becomes negative cosine to the 4th x over 4, or cosine x, the entire thing to the 4th power, plus c, Easy peasy pumpkin pie. Okay. So now let's try it with b. Okay. And so we're being asked to take the integral of cosine x over sine x dx. And what do we do here? Well, we could let u be either sine x or cosine x and get the other one in some form. But remember, when we take the derivative of u, we are going to get something blank dx. Okay? We're not going to get 1 over something dx. So that should clue me in that I want to let u equal sine x, because if I let u equal sine x, I get cosine x dx, which right in a row here. Okay? So by doing this, I can then rewrite this as, okay, this is going to be, I'm going to take care of my u substitution first, u right here, right, because u equals sine x, and du equals cosine x dx. Cosine x dx. I can put that right here, and this is just a 1. 1 du is simply du. Okay? And we know that the integral of 1 over u is the natural log of the absolute value of u plus c. And then very quick and very simply, we are done. It's the natural log of the absolute value of sine x plus c. All right, I believe that I have done all the damage I can do here. I am out. We shall see you next time.